Hello, welcome back. Hope you all students are doing great. We were discussing on the topic chemical equations and reactions. So, in last 3 sessions, we had seen what is a chemical equation, what are chemical reactions, what is or how to balance a chemical equation, why you need to balance an equation, and we were discussed about the types of reactions. There were 5 types. In that we have already discussed combination reactions. Those who have missed those sessions, please have a look at those videos and you can come back here in case if you missed. Yes, I'll continue. Myself, Samjad Zakaria, Faculty of Chemistry, Global Education Center. So let's start. In today's class, we'll be learning about decomposition reaction. In last class, we had already seen what is a combination reaction. A combination reaction is one in which 2 or more reactants combine to form a single product. But here, decomposition reaction is complete opposite of your combination reaction. The second type of reaction is decomposition reaction. What is a decomposition reaction? In decomposition reaction, a single compound, suppose if you take AB, a single compound will decompose or will get splitted or decomposes into 2 or more products. 2 or more compounds or elements, meaning to say a single reactant is getting splitted into 2 or more elements or compounds, or you will get multiple products. But how many reactants you have? You have a single reactant and it decomposes to give you more than 2 products. In combination, you add 2 reactants or more combined to give you a single product. Here, a single reactant decomposes to give you more than 2 products. Clear? Yes. Now, how this decomposition? Suppose you take AB gives A plus B. Here you see I have taken a limestone calcium carbonate for whitewashing that we have discussed there. Calcium carbonate which gives shining appearance to your walls. The calcium carbonate limestone which is present in your marble shells, which is present in your walls, which is eggshells and everywhere. Yes, calcium carbonate limestone, when you heat it, you will get quicklime, calcium oxide and carbon dioxide. This is an example of a decomposition reaction. This reaction is very important. This reaction is very important and it has lot of industrial uses in the manufacture of cement, etc. They use these reactions. Now, a question is, how do substances get decomposed? That means there should be some external energy. There should be some external energy need to be provided so that the substances or so that the reactants are getting decomposed. Here, based on the energy or based on what kind of energy you give, you have 3 types of decomposition reaction. The first one is thermolytic decomposition, meaning to say that you give energy in the form of heat. The second one is electrolytic decomposition, where you give energy in the form of electricity. And the third, you have photoelectric decomposition, where you have the compounds are getting decomposed with the help of light. So energy is here. For decomposition you use 3 kinds of energy. The first one is heat, the second one is electricity, and the third one is light. Yeah? Yes. Now let's discuss about what is a thermolytic decomposition reaction. Thermolytic decomposition reaction. Now, when I speak about thermolytic decomposition reaction, you provide heat as a form of energy. Now, you have a single product. By absorbing heat, it gets decomposed to 2 or more products. A single reactant, it absorbs heat and it gets decomposed to 2 or more products. Now, since the heat is absorbed, decomposition reactions are endothermic reactions. Endothermic reactions means the reactions in which heat is getting absorbed while the products are getting formed. Heat is getting absorbed and the products are getting formed. Such kind of reactions are known as endothermic reaction, where heat is getting absorbed. But in combination reaction we have studied, heat is getting liberated or heat is getting released. Now those are combination reactions, they are exothermic reactions. So combination reactions are mostly exothermic reaction. Decomposition reaction absorbs the heat and it gets decomposed to two or more products. So decomposition reactions are endothermic reactions. Endothermic reactions. So very first example, you take ferrous sulfate crystals in a dry boiling tube. Take a dry boiling tube and heat ferrous sulfate crystals. Ferrous sulfate crystals are green in color. It is hydrous, it has water of crystallization. We will be discussing more of water of crystallization in acid, bases and salts, but it has 7 molecules of H2O, FeSO4 dot 7H2O. Because it contains water molecules, its color is green. Now, when you take that crystals in a dry boiling tube and you start to heat it, now you are giving energy in the form of heat. Now you are taking how many product? A single product. Which is that product? Ferrous sulfate. FeSO4, which is solid crystal, green in color, you are taking it in a boiling tube and you start to heat it. When you start to heat this, you will be getting how many products you should get? You should get 2 or more products. So ferrous sulfate is heated, you will get ferric oxide Fe2O3 plus SO2 gas plus SO3 gas. You will get 2 gases here, sulfur dioxide and sulfur trioxide along with solid residue of ferric oxide. Now, when you start to heat it, this green color upon heating will lose whatever the water molecules were present in ferrous sulfate crystals and it will become anhydrous. Anhydrous means there is no molecules of water when you heat ferrous sulfate crystals. Now it becomes anhydrous ferrous sulfate. Now it will turn into white in color. When you heat this green crystal, by losing water of crystallization or by losing water molecules, it will turn to white in color. And again, excess of heating that white, when you heat it excessively, that white colored solid, it will get converted to reddish brown color. Now when you get reddish brown color, you have to understand that ferric oxide is formed. Very important questions for your exams. They'll ask this example and they'll ask you to list the observations, write the chemical equations and everything. These 2 reactions what I have written here are very important. So when that you will get reddish brown color, you have to understand that you have got ferric oxide. Now, how will you identify sulfur dioxide and sulfur trioxide gases are produced? Now, that is through smell. It will give you burnt sulfur smell. Burnt sulfur smell, meaning to say that you will get pungent smell. Pungent smell means very stinky or kind of, the pungent egg and all, how it smells. It's very, it's unpleasant smell. So you have burnt sulfur smell or pungent smell, gases are getting liberated. Now when you smell that pungent or burnt sulfur smell, you have to understand that sulfur dioxide and sulfur trioxide gases are getting liberated. Now this is a thermolytic decomposition reaction where ferrous sulfate crystals are getting converted to 2 or more products when you give heat. Now I have written this delta symbol, meaning to say that heat is given. This delta symbol indicates heat. Now let's move on to the next example where we take lead nitrate. Okay, last we have seen ferrous sulfate crystals were heated. The second example we are taking lead nitrate salt. Now these lead nitrate crystals are taken. These lead nitrate crystals are white in color. Now that salt is taken and you start to heat that using a burner, and when you heat it above 470 degrees Celsius, now this lead nitrate, a single product of lead nitrate, will start to decompose into 2 or more products. Now you give the energy in the form of heat. That's why I have written a delta symbol here indicating it is a heat, and lead nitrate is getting decomposed to lead oxide and nitrogen dioxide and oxygen gases. You will get a residue of lead oxide. Now how will you identify lead oxide is produced? Lead oxide will give you yellow in color. Now when it is hot, it will be yellow in color, and slowly upon cooling, it will get converted to white. Okay, lead oxide upon yellow in cooling, on cooling it will get converted to white. Now lead nitrate, the single product, is getting decomposed to lead oxide, nitrogen dioxide and oxygen gas. Now how will you identify nitrogen dioxide gases are produced? How will you identify nitrogen dioxide gases are produced? Nitrogen dioxide gases will be getting liberated as brown fumes. Now when you heat that lead nitrate, nitrate. Now that lead nitrate, there you can find an yellow color in the test tube, meaning that lead oxide is produced, and everywhere these gases will be brown in color, meaning to say that nitrogen dioxide gases are produced. So how will the second observation is brown fumes of nitrogen dioxide are getting liberated or getting released. So this is also an important question that can be asked for your exams. One is ferrous sulfate crystals and the second one is lead nitrate crystals. Lead nitrate will get decomposed lead oxide, which will be yellow in color, and brown fumes of nitrogen dioxide is also getting liberated. So the reactions where the products or the compound, the reactions where a compound is getting decomposed with the help of heat is known as thermolytic decomposition. The reaction where the compound or the reactant is getting decomposed to two or more products by absorbing heat or with the help of heat is known as thermal decomposition reaction, that is thermolytic decomposition. So next, these two are the examples. So next we will move on to electrolytic decomposition. When you see electrolytic decomposition, it is nothing but you have to use electricity. So electrolytic decomposition, electrical breakdown, electricity, lysis, breakdown. So while discussing this electrolytic decomposition, so electricity is used to break down a reactant into multiple products. You might have understood. Yes, electrolytic decomposition means using electricity, a single reactant is getting decomposed to two or more product, which is the energy used, electricity. Now here there is a setup is drawn. You have a plastic mug. In that you have a rubber cork. Using that rubber cork you fix two electrodes. These electrodes are graphite electrodes. Why use graphite electrodes? Those are very good conductors of electricity. Now you immerse the test tube. You have to fill it with water. Now immerse the test tube in water using this rubber cork, and inside that test tube you will have graphite rods. Yes. Now one of the test tube is connected to positive terminal of the battery, and the second test tube is connected to the second electrode is getting connected to negative terminal of the battery. Now the electrode which got connected to positive terminal of the battery is known as anode. The electrode which gets connected to negative terminal of the battery is known as cathode. Now what will happen? You have taken water in this mug. And they have experimental setup. Now pure water, you guys know, pure water is not a good conductor of electricity, or it will never conduct. Pure water will never conduct electricity. For that you have to use bit of H2SO4. You have to add bit of sulfuric acid. Now why you add little amount of sulfuric acid? So that water conducts. When you pass electricity to water, if it is a pure water, no conduction, water will act as an open circuit. Electrons will never flow. But when you add H2SO4, little bit of H2SO4 into water, now water will turn to a conducting medium or a conducting material. Now when this water is turning into a conducting medium, electron flow is possible, and adding H2SO4 will help water to have a closed circuit where electric conduction is possible. Now adding H2SO4 is for better conduction. Now what happens? You know, water H2O is like H plus ions. It will get dissociated into H plus ions as well as OH minus ions. Now this H plus ions is a cation. H plus ion is a cation. So this is a positive ion. It should move close to where? It should move to negative terminal. Positive will attract, or negative will attract the positive ion. So H2O is getting split into H plus and OH minus. Now this H plus ions are moving to negative terminal of the electrode, or the negative electrode, meaning to say it moves towards the cathode. Now by gaining an electron, it becomes H. You know, when it is a single H, it is unstable, so it combines with one more H and becomes hydrogen gas. Now you will get hydrogen gas in the cathode. You will get at the electrode where you immerse the test tube. Now towards that cathode, in that test tube, you will get hydrogen gas. Hydrogen gas, meaning to say that H will combine with other H to give you H2 gas. Hydrogen will combine with H atom, will combine with one more H atom to give you H2 gas. That means H plus gains an electron and becomes H atom. H plus ions, when it moves towards cathode, it gains an electron and becomes H atom. Now that H combines with one more H and it becomes H2. It becomes H2. Now, hydrogen gas is getting liberated at cathode. Now what about oxygen? See, you have OH minus ion. OH minus ion will move, since it is a negative ion, it should move towards the positive terminal of the electrode, which is an anode. Now OH minus will move towards anode and it will become OH by losing an electron. By losing an electron, it becomes OH. OH minus, by losing an electron, it becomes OH at anode. Now this OH will combine with one more OH to give you H2O and an oxygen atom. Now this OH will combine with one more OH to give you water molecule and oxygen atom. You know, this oxygen atom is again unstable. Now this oxygen will combine with one more oxygen to give you O2 gas. This oxygen will combine with one more oxygen to give you O2 gas. So OH minus at anode loses an electron and becomes OH. OH combines with one more OH to give you H2 and oxygen atom. That oxygen atom combines with one more oxygen atom to give you O2. These are all a little bit of extra topics. Okay, giving electron, gaining electron. Yeah, these are a bit of extra topics. Now, O combines with one more O to give O2. Now you understand how H2 and O2 gases are produced at cathode. How H2 gas is produced at cathode. How O2 gas is produced at anode. Hope you might have understood right now. Yes? Yeah. Now, you see here, H2 gas is double that of oxygen gas. You can see here, when you do this experiment, H2 gas collected is double the amount of oxygen gas which is collected at anode. Why it is? See guys, H2O contains 2 parts of hydrogen and 1 part of oxygen. H2O contains 2 parts of hydrogen and 1 part of oxygen, and amount of, you see, when during electrolysis of water, amount of hydrogen and oxygen produced during electrolysis is in the ratio 2:1. When water is getting electrolyzed or it breaks down, always 2 parts of hydrogen and 1 part of oxygen is produced in the ratio 2:1. Now that means 2 times of hydrogen gas is produced when only 1 part of oxygen is produced. That means 1 part of oxygen is going to anode. At the same time, since during electrolysis 2 parts of hydrogens are produced, now in a single part of oxygen, when it produces, at the same time 2 parts of hydrogen also getting produced, because during electrolysis hydrogen and oxygen are produced in the ratio 2:1. Very important question. Why gas collected in one of the test tube is double the amount of gas collected in the other test tube during electrolysis of water have been asked many times in exam. So the answer is this. H2O contains 2 parts of hydrogen and 1 part of oxygen, and amount of hydrogen and oxygen produced during electrolysis is 2:1. That's why the amount of hydrogen gas collected is twice that of the amount of oxygen gas collected. Very important, you can see it from this equation. Hope you understood the electrolysis of water. Next, the third type of decomposition is photoelectric decomposition. During photoelectric decomposition, light is used as an external energy. So the compound which is getting decomposed with the help of sunlight or light is known as photoelectric decomposition. Here in a China dish, you take silver chloride, white powders of silver chloride. Now silver chloride you put it in sunlight. Now after few minutes or after few time, you can see that white powders of silver chloride are slowly getting converted to grey silver and chlorine. Here a single product of silver chloride is getting into two or more products. Single reactant is getting decomposed to two or more products. Now you get grey silver and chlorine gas. Now AgCl upon sunlight, it gets decomposed to silver and chlorine. Now again bromine. Now silver bromide, same way, using sunlight, it gets converted to grey silver and bromine gas. Now this brown or black color silver bromide will get converted to silver and bromine gas. Since AgCl is white, silver bromide is brown or black in color. Now these decomposition reactions are used in black and white photography. So photoelectric decomposition reactions application is in black and white photography, since white silver chloride powder is getting decomposed to grey silver and brown or black silver bromide is getting decomposed to silver and bromine gas. Now these are the two decomposition reactions you have in photoelectric decomposition. So we discussed three types of decomposition reaction: thermolytic, electrolytic, photolytic. Photolytic decomposition, these two reactions are used in black and white photography. This finds application in black and white photography. Now with this I'll stop today's session. So in the next sessions we'll be discussing more on displacement and double displacement reaction, and hope today's class you have understood. Any doubts you can put it in comment section. Yes, so I'll stop until we see. Bye. Thank you all.